Hello viewers, today I will discuss class B commutation. So in the previous videos I explained the tank circuit and class A commutation, and the this class B commutation also depend on tank circuit, nothing but combination of series capacitor and the inductor. So this is the circuit of the class B commutation circuit, and there are two thyristors are used. This is the T1 is the main thyristor and T2 is the auxiliary thyristor, and so a charged capacitor C is the charged capacitor. So C is the charged capacitor which I placed in series with the inductor, and here a diode is used, and T A is nothing but the auxiliary thyristor, and the voltage across the capacitor, whatever we are charging the voltage across the capacitor, which is similar to the supply voltage. So whatever the charging voltage will be across the capacitor will be equal to the voltage across the supply. And now if this is the different waveforms and the gate current, this is for thyristor, main thyristor T1, and this is the gate current of auxiliary thyristor, and this is the output current. This is for thyristor 1 current, and this is the current through the capacitor, and this is the voltage across the capacitor. I took all the waveforms, and by using the waveforms you can understand how the uh, turn off of SCR, and here our intention is to turn off of thyristor T1. We should turn off thyristor T1. So this is our intention. How we are going to turn off the thyristor 1, I will explain clearly with this video. And if the gate pulse is given to the thyristor 1, this is nothing but IZ1, gate pulse is given, the thyristor will turn on and current passes from supply voltage, supply to load will be like this, supply to load will be like this. This is the process of flowing the output current. This is IA output current. The total will be the output current. So that I am taking output current, IA output is equal to 3 amps I am taking. So this is for example I am taking 3 amps. So you can understand why I took 3 amps. So I took only for the reference, and you can understand if I take a numeric one in the next slides. And so next, look at this figure, look at this figure. So after charging the, so after certain time, after certain time, so if this is the outflow of the current, output flow of the current, if the gate pulse is given to the thyristor. Now if gate pulse is given to the auxiliary thyristor, nothing but this thyristor, auxiliary thyristor, if I gave the gate pulse through this is auxiliary thyristor, that is nothing but IZ2. IZ2 is nothing but gate pulse is given to the auxiliary thyristor. So I will take a bigger one. So this is the auxiliary thyristor. So if I give the gate pulse to that auxiliary thyristor, this will turn on, this will turn on, and this positive supply of the capacitor is connected to the auxiliary thyristor, so that the capacitor will discharges its energy to the auxiliary thyristor, because this positive and positive both are positive and with the same potential, so that the capacitor cannot discharge its energy to the supply, because both are positive terminals, because this is positive terminal and this is also positive terminal. So thus both are same for both are same terminals, so that the capacitor which discharges energy to the capacitor to the auxiliary thyristor, and again inductor. So inductor, so the capacitor will discharges its energy to the auxiliary thyristor to the inductor in this direction, because this is a diode. So diode current will be, if the current flow in this direction, so because diode having the cut-in voltage, and also this is nothing but a, even though it is this is connected to the negative of the supply of the capacitors. Look at this one, this is negative supply, that's why the current cannot flow to the diode. So the current can flow only to the thyristor to inductor. So the inductor, the capacitor total will discharge its energy to the inductor. And look at this one, the before turning off the, so observe this diagram. So this is the turning position of auxiliary thyristor. This is the auxiliary thyristor. If I give the gate pulse at this position, look at this one here, look at this one, current through the auxiliary thyristor inductor will be sinusoidal manner. So sinusoidally increases and reaches to the peak point, and this is up to inductor charges, up to this peak point inductor charges, and inductor will discharges, and capacitor will charges with the reverse polarity. So with reverse polarity is nothing but this positive and negative. I will explain in the next picture. So this is all about even though the auxiliary thyristor, the current flows through the auxiliary thyristor, then there is no disturbance to the thyristor T1, because the current flowing through the T1 from the supply will be constant. This is constant, and the output current is constant. That is, I took 3 amps at the first diagram. So current through the thyristor also 3 amps. And then if I take a next diagram, observe carefully. So this is up to, this is up to previous diagram. Now if at this position, look at this one, at this position, so here the capacitor voltage will be reverses. In the previous diagram, observe here, in the previous diagram, if you see, this is the capacitor and this is the inductor. If you turn on the auxiliary thyristor, the energy transferred to the inductor through this auxiliary thyristor, and this act as a tank circuit, and current flow through the inductor and capacitor will be sinusoidal in this way. And while charging the capacitor, while charging the inductor, polarities will be positive and negative, and if the total energy of the capacitor will be transferred to the inductor, then after absorbing the total energy from the capacitor, inductor will be changes its polarity, and it will discharges to the energy to the capacitor, and in this direction, so that the capacitor will be charges here positive and negative. This is positive and negative will be reverses automatically while charging the capacitor. Look at this one here, this becomes positive, and this becomes negative. The capacitor charges in this direction. Now observe carefully at this position. So at this position, capacitor is reverse charged. Capacitor is at T2. Observe carefully here, the capacitor voltage is reversed. So the reverse to the previous one. Previously the capacitor voltage is positive, and now that becomes negative. So negative nothing but this is, look at this one, this is negative, and this is positive, and this is positive, and this is negative terminal. So that negative voltage applied across the thyristor, and a current in the thyristor is 0. So at this position, look at this one, at this position, current in the capacitor flowing through the current flowing through the inductor and capacitor is 0 at this position. Observe this one, and at that point voltage across the auxiliary thyristor is reverse polarity, so that automatically auxiliary thyristor will be turned off. Auxiliary thyristor will be turned off. As we know that if you want to turn off any SCR, so there are two conditions. First one is current through that SCR must be 0, and if you apply negative voltage, reverse voltage to the thyristor, then if you satisfy these two conditions, then the thyristor will automatically turn off. So these two conditions is satisfied for thyristor, auxiliary thyristor. So at this point, current is 0, IC current is 0, and voltage across the auxiliary thyristor will be with a negative polarity, so that auxiliary thyristor will be turned off. Auxiliary thyristor will be turned off. Now look at this one. So at previous output current, in the previous diagram I took output current as 3 amps. Now observe here, this is positive terminal of the capacitor, and this is negative terminal. So that look at this one, capacitor discharges its energy through the diode in this direction, and output current is should be constant, that is 3 amps. Output current should be 3 amps. So for example, current through the diode is 2 amps I am taking. So definitely current through the from the supply is 1 amp. So according to the KCL at this node, 1 amp is entering, 2 amp is entering. So that the output current should be 3 amps. So output current after this point, look at this one, after this point, output current is constant. Output current is constant because 3 amps, that is constant, and slowly, because at the previous case current, output current is 3 amps, but in the absence of capacitor current, output current is 3 amps from the supply, but now capacitor current also added, so that supply current will be reduces, and supply current will be reduces nothing but current through the thyristor 1, current through the thyristor 1 will be reduces in this way and decreases. After a certain point current will be decreases. After a certain point current through the thyristor 1 will be decreases, and look at this one, this is the capacitor capacitor voltage, which is with this polarity, and negative is applied to positive terminal, and positive is applied to the negative terminal. So like this negative terminal of the main thyristor, and that is the current through the, at this point, look at this one, at this point current through the auxiliary thyristor will be 0, and while charging the small, look at this one, while discharging the small current, after discharging the small current of the capacitor, after discharging small current from the capacitor, the thyristor current will be become 0, and then voltage across the capacitor, even though small charge will be discharges, capacitor voltage will be negative only, VC is negative only, and at this stage, look at this one, at this stage, at this point current through the thyristor 1 is 0, and at this point voltage across the thyristor 1 is negative. So the two conditions are satisfied. So if you want to turn on the any thyristor, the current through the thyristor should be 0, and negative supply should be applied, negative voltage should be applied across the thyristor, then only voltage across the sorry thyristor will be turned off. So here also thyristor 1 thyristor 1 also turned off automatically in this direction, in this way, so that the thyristor will be turned off in this way. This is called class B commutation. So thank you for watching.